Evaluate the definite integral. And here we have the definite integral from a to the square root of 3 times a of x cubed minus x divided by 2 dx. So this is all set up for us. Don't be intimidated by these weird bounds. Everything is going to be exactly as it was before. So we've got the definite integral from a to the square root of 3 times a of x cubed minus x divided by 2 dx. And so both of these terms are general antiderivatives. This integrates to x to the fourth divided by 4 minus x squared divided by 2 times 2. Right? You don't want to forget about that 2 from the original integrand, and this new 2 comes from antidifferentiation. And so we can evaluate this from a to the square root of 3 times a. And so let's see here. We, of course, know that 2 times 2 is going to equal 4. So notice that both of these terms in the antiderivative have a common 1/4. So let's pull that out to the front before we evaluate. So we have 1/4 multiplied by x to the fourth minus x squared. And we're ready now to evaluate from a to the square root of 3 times a. And so here we go. I'm going to keep that 1/4 on the outside. So we're plugging in the upper bound. So I have the square root of 3 times a to the fourth minus the square root of 3 times a squared minus, and now we're evaluating at the lower bound, so this will be a to the fourth minus a squared. All right, so we got to apply some properties of exponents here. So just for a friendly review, I'm going to drop down and think about the square root of 3 times a squared. So by the properties of exponents, we can think about this as the square root of 3 squared times a squared. So with the first term, the square root and the square cancel each other out, leaving us with 3a squared. Now, if we extend this to the square root of 3 times a to the fourth, again, we could distribute that 4 through, but you can also think about this as the square root of 3 times a squared multiplied by the square root of 3 times a squared. And the reason I'm separating it out like this is to take advantage of what we just found. So we know that this is going to be equal to, from this first step, this will be 3a squared multiplied by 3a squared. So 3 times 3 will give us 9, and a squared times a squared is a squared plus 2, or a to the fourth. And again, a squared times a squared is a to the 2 plus 2, which gives us a to the fourth. So the hard work is done. We have the square root of 3 times a to the fourth done. And we also have the square root of a squared done. Woohoo! So let's plug these in. So there's my little algebra lesson for the day. So this leaves us with 1/4 multiplied by, we have the square root of a, or the square root of 3 times a to the fourth, which left us with 9a to the fourth, minus the square root of 3a squared left us with 3a squared. And now we're going to subtract that lower bound. So we have no evaluation that needs to be done here, so we can go right ahead and we'll distribute that negative sign through. So this will be minus a to the fourth plus, negative times a negative gives us plus a squared. And look at all these like terms we have. We have 9a to the fourth minus a to the fourth, and we also have minus 3a squared and plus a squared. So this leaves us with 1/4 multiplied by 8a to the fourth minus 2a squared. And when we look at this, we realize we have a greatest common factor of 2a squared. So let's pull it out. I've got 1/4 multiplied by 2a squared times 4a squared minus 1. And we can cancel again. We see that we have 2, or we know 2 goes into 4 2 times, which leaves us with that beautiful final answer of 1/2 multiplied by a squared times 4a squared minus 1.